Special method names are a topic particular to the Python language. Certain names in Python are special because they have built-in behavior of some sort. And they always look the same. They always start and end with 2 underscores. So when you see a name with 2 underscores around it, that's just an indication that it has some particular behavior. It interacts with the built-in object system in some way. For instance, the first one we saw was init. This method is special because it's invoked automatically whenever an object is constructed. Other than that, it's just a regular method. Repr was discussed in the previous videos. It's the method that gets invoked in order to produce a string that represents an object, and it's the one that's used in an interactive Python session to display the value. What about add? Well, that's a new one. This is a 2-argument method that's invoked to add one object to another. There's a 1-argument method called Bool and another called float. This one is invoked to convert an object to true or false, telling you its Boolean value. And float tries to convert an object to a real number. So, for example, if I set 0, 1, and 2 to 0, 1, and 2, and then I add 1 and 2, I'll get 3. If I'll call bool, which is a built-in function, on 0, I'll get false, and on 1, I'll get true. And this bool function gives you exactly the behavior that you'll get if you place these objects in a Boolean context, such as a conditional statement. Now, it's possible to rewrite this entire sequence of statements. I could say 0, 1, and 2 or 0, 1, and 2, and then add 1 and 2 together using the special method name. Or convert 0 and 1 to Boolean values using that special method name. So there's a correspondence between built-in pieces of syntax and built-in functions and these special method names that actually do the work. It's another example of using an interface in order to allow user-defined objects to interact with the built-in systems within Python. So Python is very extensible. You can create a new class and be able to add instances of that class together using the plus sign just by overriding the special method name add. So what happens when you have 2 instances of user-defined classes added together? Well, what happens is that you invoke either add, or there's another method called radd. I'll tell you about that in a moment. And that actually performs the addition. Again, we're just asking the objects, how do you add yourselves together? So if we want to extend our ratio class so that we can add ratios, this is certainly possible. I could add a third and a sixth to get a half, either using the plus sign or by using the method that actually performs the addition. Both of these expressions are equivalent in Python. Now, people almost always use this one because it's much easier to read. The purpose of this is just to allow ourselves to use the method definition syntax in order to override what happens when you use a plus sign between 2 objects. You can also use radd. The difference between radd and add is that this here is the argument on the right side of the plus sign, and this is the argument on the left. Now for numbers, addition is commutative, so it's irrelevant what order they come in. These 2 functions are equivalent. But you could imagine some cases in which you'd like to invent addition that's not commutative, and so it is possible using radd. I'm not going to go through every special name and how it corresponds to some built-in feature of Python, but that has been done before you, both in the Python docs and in this online textbook called Dive into Python 3. But let's see if we can add addition to our ratio class. We define an add method that takes self and other, and what it does is just computes the numerator and denominator of the result. So the numerator of 2 added ratios is the numerator of the first times the denominator of the second plus the denominator of the first times the numerator of the second. The denominator is the product of the denominators. If we want to reduce this ratio to two relatively prime integers, then we have to compute the greatest common divisor of n and d. Then we can return the ratio of n divided by g and d divided by g. And what's the greatest common divisor? Well, we did talk about this earlier in the course. One way to compute it is to say, while n does not equal d, we rebind n and d to be, in no particular order, the min of n and d and the absolute value of n minus d. So now we can take the GCD of 12 and 8 and get 4. We can also add together the ratios 1/3 and 1/6. Now maybe we're not done. What happens if I add together the ratio 1/3 and 1? I should get 4/3, but I'm assuming that the thing that I'm adding this to is in fact another ratio, as opposed to an integer. One thing I could do is inspect the type of other in order to figure out what action to take. So I could say, if it's the case that other is an instance of the int class, then instead I have a numerator that's the self.numerator times, well, the other denominator is just 1, and then I add in self.denom times the other, which is the numerator of the other. Here I'm just treating other as a numerator of other and the denominator of 1. D is the denominator of self. Otherwise, if it's the case that other is an instance of the ratio class, then I use the formula that I had before. I can still take the GCD, and I think I'm back in business. I can add the ratios together, or I can add 1 to the ratio. Now can I add a ratio 1/3 to 1 in this order? Not yet, because I don't have right side addition defined. But I can just say that right side addition is the same as addition for this class. At which point, I can add ratios, I can add integers to ratios in either direction, and I've fulfilled the interface for adding addition to a user-defined class in the Python language. Now what happens if we add a floating point value, 0.345? Well, then this result will not be an integer. So it doesn't seem like we should be building a ratio at all at that point. There's another option. Instead, we could convert our existing ratio into a floating point value as well. By that, I mean I just detect if other is an instance of float. And if so, I return not a ratio at all, but instead what I get when I convert self into a float and add it to other. Now what does it mean to convert self into a float? Well, I have to define that. I define that using this special method name, or in this case, I'll just return what you get when you divide the numerator by the denominator. So I've extended my system yet further, where now I can add 0.2 to the ratio 1/3, and I'll get some reasonable result. I've actually used two important ideas here in one example. This is called type dispatching, where you inspect the type of an argument to decide what to do. And here, this is called type coercion, which is when you take an object of one type, convert it into another type, in order to be able to combine it with some other value. These are two strategies that people use in order to have different classes interact. Add is a two-argument method, and now we have a version of add that operates on two values of different types.